Okay, so let's draw the shear force and bending moment diagram for this frame. The first thing we'll need to do is find our reactions. So I'll call this point A, and we'll have reactions AX and AY. Call this B, and we'll call this C, so I'll assume a CY. And as I'm applying statics to find my reactions, I'm probably going to want to use the concentrated equivalent of this distributed load, which should be the area of the curve, which is 12 feet times 3 kips per foot, 36, and located at the centroid of that area, which is halfway. So with that, I can sum moments. I think I'll sum moments about A, the pin. That'll eliminate 2 of my unknowns. And I'll find, I should be able to solve for CY. Now both these forces about A are going to create what kind of moment, positive or negative, using my sign convention? Negative. So I'll have negative 36 kips. And the moment arm there is 6 feet. My paper's kind of riding up there. And then I'll have negative 15 kips, and that moment arm is 4. And then I'll have CY times 8. So I should be able to solve for CY. Oh, I need some help with that. Anybody got any ideas? 34.5?
Yeah, 34.5. Did you just take out that other bar?
I'm sorry, what?
From the original problem we were looking at, you just took out the other bar?
I just took out the other bar.
That's what it is.
There is nothing on from C to D. And then we'll sum forces in the Y direction. So I've got AY plus CY minus 15. So that should give me AY. So whatever 34.5 minus 15 is, what is that, 19.5? 18.5? And that should be negative, right? No, yeah. Is that right?
Yeah.
Yes.
It's just negative 19.5.
Oh, I don't like this. Something didn't go right. Hang on a second. Let me think about this for a second. Okay. I like it. Took me a minute. I'm slow. Didn't have my tea this morning. All right, so let's sum forces in the X direction. I have AX plus 36. So AX needs to be minus 36. I've got my reactions. Any questions about that? So we need to break it apart here at B, and you can either work AB or BC. I'm going to suggest BC will be simpler. So I'm going to come down here and do section BC. So I'll redraw that. I have the applied 15 kip force. I have my CY reaction, which is 34.5 kips. And then I'm going to have at B, BY, BX, and then a moment. I'm just assuming directions for all those components. So I need to find those. Easiest way to do that is to sum the moments at B. So summing the moments at B using right-hand rule, my moment is actually negative. The moment created by the 15 kip force is also negative with a moment arm of 4. I didn't put my dimensions in, sorry. And then this reaction force at C creates positive moment, 34.5 kips times 8 feet. So what's my moment at B? It looks like it's going to be positive. Whatever that, what are those? Add those things together. This is 60. I don't know what that is.
216.
What do you get?
216.
216?
Yeah.
And that'll be kip feet. And then we will sum forces in the y direction. So I have By acting up, minus 15 kips down, plus 34.5 kips up. So my my reaction at B is 19.5, right? Negative. And that's it. We can check, but I think you can see that if I sum forces in the x direction, all I have is Bx, so Bx is 0. So I'm going to cheat a little bit, and I'm going to squeeze in the shear force and bending moment diagram right here underneath this guy. It'll be kind of tight, but I think we can do it. So what's the shear start off with? It starts off as By. Is that positive or negative shear? We saw for By as negative 19.5, so it's actually down. So what kind of shear is that? That's negative shear. So we're going to start off at negative 19.5. Now, remember, the change in shear is equal to the area under the load curve. What's the area in the load curve for the first 5 feet? 0. So it's going to stay 19.5. And of course we know that the slope of the shear diagram is equal to the load, right? Those relationships. And the load is 0, so the slope is 0, so it stays constant. Then what happens is we go from the left to the right side of this 15 kip force. We drop shear by negative 15. And that should give us 34.5. The change in shear is the area in the load curve. Load curve is 0, so no change. And it matches the negative 34.5 value at the end. The slope of the curve is the load. The load is 0. 0 slope. So we have this kind of stepped shear diagram. All right, let's do the moment. So there's the load, positive moment, units of kip feet. So what's the bending moment at B? We solve that as 216. What kind of bending moment is that? Positive or negative? Positive. So we're going to start at positive 216. the change in moment is the area under the shear diagram, right? So what's the area of the shear diagram for the first 4 feet? 4 times 19.5. What's that?
78. 78.
So what's 216 minus 78?
138.
What's the slope of the moment diagram? It's the shear. So the shear starts out at negative 19.5 and stays that way, so it's a constant slope. Negative slope. The change in moment over the next 4 feet is what? It's the area under this part of the curve, which is 4 times 34.5. Hopefully that's 138. So that brings us to 0. The slope is constant and negative. So there's my moment diagram. And we are out of time, unfortunately. Sorry about that. So all that's left to do is this section AB. We'll have to do that some other time. Sorry about that. You guys can finish this problem if you want it as practice.